Today's lesson is on big and small endian. What does that even mean? I mean, you can make some sense of it based on the words, but let's go a little bit deeper. The term stems from this one scene in the classic Gulliver's Travels. In the scene, the characters are discussing how different people like to eat their hard-boiled eggs. Some people like to eat their eggs from the small end, little endian, and some people like to eat them from the big end, big endian. Regardless, both ways, you still end up eating the egg. How does this have to do with computers? Well, it's because of this guy. David Cohen was born in Israel and studied math and computer science at Harvard and Caltech. He coined a term in the realm of computers, and more specifically, memory. So what is memory? Since the most basic Turing machines, memory has always been an integral part of how a system stores things that we already know. The idea of storing things is easy. However, the task of knowing where to store them and how to store them is the hard part. Memory is one large array. Imagine a tape from a Turing machine or an array. Each location has an address, just like every house or street has an address. The address in computer talk is called the index. To continue with this house analogy, each plot of land in the street is generally the same size in the real world. In computers, we're a bit more strict about this requirement. Usually each index has a size of a byte, it's 8 bits, but this can be different as long as all the other indexes are the same size. When an address contains a byte, the memory is called byte addressable. There are occasions when each byte stores a nimble, or a bit. So what happens in memory lane when you're really rich and want a house 4 lots big? Well, you have to buy 4 lots. Each lot is still separate, and each lot is still the same size. This is how we store things in memory that are larger than a single byte. So what does a half-eaten egg have to do with memory? So you're Mr. Richpants and bought 4 lots for your massive house. How do you keep track of what part of your house is in each lot? Well, if you're the kind of rich guy that eats his eggs from the big end, you would do the following. You would have your front door in the rightmost lot of your property, closest to the start of the street. You would have your mailbox here, you have the most important parts of your house here. You would have other things such as the rooms and the kitchen in between, and you'd have the least important parts of your house at the end, something like the garage or the storage. This makes perfect sense. After all, it's how humans read. It only makes sense. Your friend across the street, Mr. Rich Trousers, has a different idea about how he eats his eggs, and therefore how he builds his house. He thinks that his front door and all the important parts of his house should be in the leftmost lot, while the least important part should be in the rightmost lot. One day, both of you decide to do a reno at the exact same time. Well, because you built your house near the beginning of the street, and the reno company can only do renovations from the lot closest to the beginning of the street towards the end, then you have to move out for a while because the most important parts of your house are being renoed and you can't use your house. On the other hand, your friend with the little endian house, he doesn't have to care about that so much because they are starting with his garage and the least important part of his house. This is synonymous in a computer with arithmetic. You add and subtract first with the least important parts of the data, and then you work your way up towards the most important parts. This can save some time in terms of calculations, and it's a very, very short amount of time, but once you go through millions and millions and millions of computations, it can add up to a significant amount. A few months later, a huge volcano erupts near your city. Well, this is really bad. You and your friend are both trying to get back to your houses to check the damage. Because you decided to build your house closest to the start of the street, it means you can check the damage really quickly, while your friend has to drive through many of his lots to finally get to the most important parts of your house. Well, how does this relate to computers? In computers, when you want to check for damaged information or damaged data, you always check the most significant part first. So with big endian computers, this can be a lot easier. Okay, so who uses little endian and big endian? Well, this is little endian. AMD, Intel, Antera, Apple. Who uses big endian? Well, it's Motorola and IBM. You probably get why there's only 2. You get the point. Finally, here's some questions that you can try and mull through in order to better understand big endian, little endian, and converting between each other. I hope you enjoyed this, and I hope you know exactly what little endian and big endian are now. Thanks so much.